Hello and welcome to an impromptu live stream with great friend of the show, Roofus, and a longtime personal friend of mine, Mark. Great to have you guys. I'll hand it over to you, Roofus, to introduce yourself as well as talk a little bit about Electric Universe, and then we'll hand it over to Mark.
Oh, so is it my turn?
Yes, dear.
Okay, well, my name is Aaron. That's no secret. So you can call me Aaron. You can call me Rufus. You can call me Ray. You can call me Jay. Um, I'll respond to Aaron. I'll respond to Rufus. My channel is Rufus Cat 2, whose name with a question mark, and I know that's a long name for a YouTube channel, and that's a long end. I won't even go into why. Okay, that's all. I just left it the way it is. Let's just go with that.
I will add your channel to the description of the video, and people, if you are interested, please subscribe.
So it's Rufus Cat 2, whose name. The reason it's Rufus Cat 2, I did have a termination because I was a YouTube bad boy and I posted some things that YouTube didn't appreciate, like videos on David Hogg and videos on Las Vegas, trying to expose errors in the narrative of various events in our past. So YouTube didn't like me very much, and I did earn myself a termination. So it's Rufus Cat 2. Anyway, so what I do is mostly for the last 2 years, I run a show called Conwick, which is Conspiracy or Not Here We Come, the anagram CONHWC, and Conspiracy or Not Here We Come. We talk about all kinds of things, very much like you do. Anything interesting, anything conspiratorial related, and pretty much almost everything is kind of related to conspiracy in some way or another. So it's pretty much an interview series. I've had some big names, big hitters. I've had a couple of well-known, world-class researchers and authors as interviewees, and a couple of interviews that I'm very proud of. Other than that, it's pretty much an interview series that I've been doing for. We've been doing it for 3 hours every Friday for the last 2 years. And we took a sabbatical, so for the last 6 months, you won't see much in the way of those interviews, at least 6 months. But we're starting to get back on the horse again. Anyway, that's kind of what I'm about. That's what my channel is about, is sort of doing what I can to expose errors in the quote-unquote narrative, as it were. And that's really what I'm about. And, I do what I can to forward the truth community in the best way that I can. So that's me.
Awesome, thanks. And yeah, you had come on to a previous stream, which unfortunately I had private because there were some slurs made on it, which I don't really want on the channel. And so you had talked a lot about Electric Universe, so that was very interesting, and that was what made Mark interested. So Mark, we'll hand it over to you.
Yeah, it's Mark here, longtime friend of Jen's. Boots in the seat in the office for a solar company doing all sorts of electric. But I have experience with the practical side of what was going on in the conversation. I was very much interested to get it continued.
Great. So where do we want to start? Does we want to give a little description of Electric Universe?
Well, you brought on Mark for a reason. Tell me why.
Well, I've actually wanted to get him on for a while because he's an awesome guy, and I think people will really like him. And he's one of my friends, so obviously, I think basically his interest in electricity would be a good fit for this type of conversation. I didn't really have an agenda past that. I just like to facilitate conversations between interesting people, and because you're both interested in Electric Universe, I figure I could facilitate that today.
Okay, so knowing that we were going to be probably talking about Electric Universe, or at least furthering our conversation on Electric Universe, you brought on Mark because, from what I understand from my brief offline chat, he has a background in electrical engineering. Is that correct?
Correct.
Yeah, I don't know if
and good old-fashioned nepotism.
I don't know if you nepotism. I don't know if you want to talk about your job, but it's a pretty interesting job, Mark. What you do.
Yeah, I mean, I've been almost 9 years now designing and assisting with the installation of solar projects on very small scale to actually pretty large scale. So and in on the engineering side of that.
So Mark, would you would it be fair to classify you as an electrical engineer?
No, actually, I'm not. I don't have a ring because I wouldn't want to spend that much time in school. But no, I'm a senior technologist.
Senior technologist.
Yeah.
In the field of electrics of sorts, right?
Yes.
So could you maybe could you just clarify that a little bit more for me and the audience?
Yeah, sure. I studied electrical or electronics engineering, and then energy systems engineering in college. So not university educated, but it's certainly this stuff works.
Okay, well, I'm not university educated either, but
Fair
just
enough.
to give you a little bit of my personal background, I was pretty much a straight A student as I went through high school, and I did take 3 years of electronics in high school, and the first year my high school offered electronics, I took that course, and myself and one other student were advanced students. So we were allowed to move forward beyond the rest of the class. And it was because of myself and one other student that my high school offered electronics 3, 4, and then 5, 6. Okay, so first year electronics 1, 2, 2 semesters, and then the second year, because of me and one other student, advanced as we were, my high school offered electronics 3, 4, and then the following year my high school offered electronics 5, 6. So bottom line is, me and one other student were solely responsible for my high school advancing their courses in electronics. It was us that did that. If it wasn't for us, my high school would probably not have done that.
Good
So
on you.
so bottom line is, I did very well in school. I did very well in high school. I did very well in math, very well in science. I thought for a while I was in school that I would proceed to be an electronic engineer. Okay. So that was the career path that I began to take. So that's, and after high school, strong divergence. Okay. It didn't happen. Um, I, I, I did work in the field as a electrical apprentice, as far as like residential wiring and commercial wiring. So, I mean, it's not like I'm ignorant to these things. Okay. So
Mhm.
I do have a background in a relatively, I wouldn't say strong, but maybe strong. You know what I mean? You understand.
Yep.
So I do
Yeah,
have a
fair enough.
background in these fields. So I'm not ignorant at all. Okay.
Right on.
So, all right. So we started out with Jen and I were talking about Electric Universe. She wanted to talk to me, and this is the second. Well, actually, today will be the third. So my interview with Jen a couple of weeks ago would have been my second interview on the subject of the electric universe. Okay, so here I am. I'm not a PhD. I'm not a physicist. I'm not a scientist. I'm not an electrical engineer. I don't have any letters behind my name. Okay, I'm not a classical trained, electrical engineer. All right. But here I am being interviewed trying to defend this concept of the electric universe. All right. So,
Yep.
all right. So
Oh,
now you
hence
have a
all the
feel.
references, right? Yeah, fair enough.
Right. Sure. Okay. So
Yeah.
now you got a feel for what I'm about and what we're doing here.
Yeah, right on.
All right.
It's
Okay.
that's funny. I was one of two people to get an advanced math course back in grade 6 or 7, and then also took off to another school for a program called Net Solutions, which is very much computer and electronics oriented. Built my first multiplexer circuit back when I was about 16 or so. But yeah, awesome.
Okay. Well, I was, me and this other guy, Pat, me and the other advanced student, we were building lasers, and I created a device. And this is when I'm a
Wait,
sophomore.
building lasers or assembling lasers? Because there's a
Excuse me,
huge.
assembling, because
Okay, fair
obviously
enough. Yeah,
we
yeah.
weren't inventing anything. Okay, but we were high school
Yeah, yeah.
students.
Okay.
Okay,
Yeah,
Okay,
no,
so
fair enough.
well, we were still way ahead of everybody
So-
else in our class.
Just to clarify.
Yeah. I wasn't inventing anything. But you know,
Yep.
and again,
That's me too.
so I did create a device that would turn sound into light, and I shot that light across the room in our class, and I reconverted the light back into sound. So again, I wasn't creating or inventing anything. It was just, you know, I was a high school student. Okay, so that's sort of the stuff that I was tinkering with in high school. All right, so we've established a little bit of background. So, everything went dead silent.
I'm still here. I'm just trying to
Okay,
think of
okay.
what the best, like, because we could talk about different things. Like, we could go into what electricity actually is and how
So,
electromagnetism relates to quantum field theory, or if you
okay,
want to go into electric universe, because I don't know if Mark has actually heard about electric universe. I've definitely heard about it. Some people in the chat have come on several times and said that I should talk about electric universe. But basically, I already have my own unified field model. So I do accept that there is such a thing as electricity. It is a quantum effect. And I'm basically cool with that. So
so the first thing I want to ask Mark is electricity scalable? Do you agree or not that electricity is scalable?
Scalable. What's your definition of scalable? Yes, you can have larger voltage, larger current, larger watts. So in that sense, you know, you can scale up from small electric power to a large electric power.
I think what he means is, do electric fields manifest on all orders of magnitude?
In all orders of which, sorry?
All
All
orders of
orders
physical
of
magnitude.
magnitude.
Like, for example, is the electricity, are the field equations for the electricity that we use in our homes, are those the same field equations as the electrical field of the sun, which is many orders of magnitude larger than what we see on Earth?
I would assume yes.
Yeah, I think we're all on the same page with that, because in my model, the fields are what you call fractal, which means they're the same on every order of magnification. So no
Okay.
matter how
Yeah.
big or
I mean,
small,
E equals IR Ohm's law tends to be
E equals I
universal.
over R. Correct.
Yeah.
That's right. That's correct. Okay. So
E
E equals
equals
I over.
I times R.
Sorry. Yeah, that's correct. Okay.
Yeah.
So when I walk across my rug in socks in the winter, when the air is dry, and I induce an electric charge in my body, and I touch a doorknob or my brother on his ear, and there's a little static electrical arc between my finger and my brother's ear. We've all done that as kids, right? So that little
That's
electrical arc is the same as a scalable lightning bolt.
well,
Yes?
yeah. I mean, the voltage, the potential it's a linear function regarding how far of a gap in air it can travel.
Correct.
Right. And yeah.
According to
Yes.
voltage, yes. According to voltage, that's correct. That's right. So the voltage for the layman, voltage is push, voltage is a force, and amperage is the amount of electrons that travel. So if you think
Yep.
of a water pipe, there's pressure and then there's volume. So you can have a big water pipe and lots of water moving very slowly. That would be a low voltage and high amperage, right? So a comparison to a water pipe. This is the easiest way for the layman to understand is water, right? So if you have a giant water pipe, let's say 10 meters in diameter, huge water pipe, and the water's moving very slowly. That would be an enormous amperage, but low voltage.
No. No. See, you're boiling things down to power is what you want to do, right?
Sure. I'm just trying to
Amperage.
boil it down for the
Yeah.
layman.
Yeah. Fair enough.
Okay?
Yeah.
I'm just trying to make it easy for people who are not familiar with electrical terminology, electrical physics,
Yeah.
to
So
understand.
low voltage, high power. Yeah.
Yeah,
Oh,
voltage and
yeah.
amperage. So we have electricity, which are electrons traveling in a pathway. whether that pathway be a wire or the air or a plasma field. Okay, so we'll get to plasma in a minute. But for the layman, I just want to make this very clear for those who are not familiar as you or I might be, or Jen. Okay, so to make it very simple, if you have an enormous pipe, 10 meters in diameter, flowing water, tons and tons, big pipe, and the water's moving very slowly. Think of every water molecule as amperage, and think of the force which pushing the water as voltage. Right?
Yep.
Okay, so we're on page. Everybody's on board.
Just to go into the explanation a little bit more deeply, one thing I wanted to mention was, so if we think about, I think for the laity, the best way to explain this stuff is with a concrete example from real life. So we all have electricity in our homes, presumably. And so the question is, when you plug something in, how fast does that potential manifest from its origin point? Does anyone know?
How fast? Speed of light?
Yeah, speed of light. So that's an important distinction. So there's some type of field there that is transmitted at the speed of light, and that's the voltage difference, correct?
Right, and the correlate or the relationship with resistance is if you have like a small LED light that takes 3-5 watts or whatever, the resistance is very high, and which dictates that the current is very low.
So it's resisting this difference in potential with a very high degree of what do you call it? It's very efficient.
Resistance.
It's very efficient at resisting this difference in voltage, which is huge, right? So
that's correct.
It only gets a tiny bit of energy delivered to it, and ultimately everything boils down to energy, which is why Mark was talking about power, because power is energy per unit time. Correct?
Correct.
Yes.
And
now there's a strange phenomenon that takes place, because regardless of voltage and regardless of amperage, we're still talking about the speed of light, because the effect is the same. It still happens at the speed of light. Right? Even if it's low voltage, low amperage, the speed of light is still the same. It still happens at the speed of light. Electrons don't travel slowly.
but there's no actual electrons moving. So this is the distinction I wanted to make. There's a voltage difference, which is transmitted at the speed of light, but then electrons have what you call a drift velocity, and that's way slower. So
yeah.
Go ahead.
Well, I was going to say power is coulombs per second, so it's the amount of state change per second. I assume that transition from not having an electron to having an electron is going to be fairly static. Is it, Jeff?
I'm not sure what you're saying.
So the amount of energy out that you can get over time is the amount of
that's the amount of work. That's the amount of work that you can accrue. The amount of energy you can get over time is equal to what we call work. So, I mean, that's what we derive from the force and the energy that we produce.
Yeah, so in short, the electrical force is very well understood, and we have a series of what are called field equations that basically predict all types of electric behavior. And our ability to make these field equations that more or less started out, I think, with the Gaussian relation, that is what has allowed us to harness electricity to the efficacy that we have been. And so that's important. So the question is, can this force, this electric force, be used to explain not only what we use in our homes as electricity, but in fact, everything in the universe? And that's what my impression is about the electric universe, though I could be wrong.
I would disagree with that. And my bad, it was joules per second, not coulombs per second. But
so let's just look at electricity briefly let's just in our minds for a moment, let's go from the micro to the macro. Okay? And a single atom is a proton and a neutron, or a cluster of protons and neutrons surrounded by a shell of electrons. Electrons are what we call electricity. Yes, everybody on board? Single atom.
What we call electricity is actually voltage potential difference.
Yeah, I was going to say you have to have two different atoms with different numbers of
I understand
electrons.
I understand the differential, but for
right, but a
again,
singular atom can't be electricity given the number of electrons that it has.
Okay, I understand. I'm really in my mind. I'm speaking to the layman. Okay, so I understand there's an audience.
Is there though?
Well, there's a small audience.
I guess there is. I don't know. I'd rather keep it a little more high level than flowing water, but that's just there though.
Okay, well, I just wanted to move because trust me, I'm going to move all the way up to the grand macro scale.
All right.
So my question to you was that is electricity scalable? Mm-hmm. So atoms, whether they're electron shells, we have electrons orbiting the nucleus of an atom, and two atoms come together to make a molecule, right? There's an electromagnetic bond that occurs, right? You tell me when I'm wrong. And then we have we scale up from molecules to say let's just jump forward to biology, a single cell. Now, cellular structures operate on electromagnetism. Every operation within a single cell is governed by electromagnetism. Whether or not it takes in various nutrients or whether it expels various excretions, okay, molecules and minerals that it doesn't like. So let's scale up to a human being, a bodily function of a human being. You cannot take in oxygen and have your body use that oxygen without the movement of electrons. Every blood cell in your body takes and loses electrons. The oxygen molecule is considered caustic. So, in other words, the oxygen molecule is kind of unique in the chemical realm, is considered caustic. So, everything that it comes in contact with, it either steals an electron or it gives away an electron. Tell me when I'm wrong, okay?
Mm-hmm.
Okay. So, as far as blood works, as far as oxygen works, and oxygen is a molecule, H2O, two oxygens, one hydrogen. So, electrons and electromagnetism are necessary for chemistry. All chemistry is based on the movement of electrons. Yes?
Yes.
So, you broke up there.
That is correct. All chemistry is essentially magnetic transitions. Yes.
Okay. All right. So let's move up from there. Now let's go to the full biology. A human being, an entire human being. I walk across my carpet with my socks in the winter, and I accrue an electrostatic charge, and I can touch a doorknob or the ear of my brother. Right? I can walk up to my sibling and touch him on the arm and zap, pow, static electricity, pow. Right? So now we have an arc. I have built up so many electrons and there's a differential. I have too many, he doesn't have enough. Electricity jumps from me to him, and I don't even have to touch him. All I got to do is get close enough and the electrons will jump from me to him. Electrons are doing that. Electricity is doing that. Yes?
Mm-hmm.
So that is a thunderbolt. So let's scale up even further. Now we have a planet. We have an atmosphere. We have a molten iron core. We have a crust that is full of magnetite and electromagnetic chemicals and minerals, right? So apparently there's a huge differential. So there's an electrostatic buildup in our atmosphere. And that electrostatic discharge occurs when there's a huge differential to the point where it can't hold anymore, and the discharge occurs. Bang, electricity.
It's
Yeah.
not that it can't hold anymore. It's just that it's in close proximity to something that has an opposite charge.
Okay. Well, fair enough. It's in close proximity. Bottom line
Yep.
is it really can't hold anymore in that locale.
And just to be clear, even if something is neutral relative to a positive or negatively charged system, that's still considered a quote opposite charge, right? Because what you're looking for,
Yeah, potential difference.
a potential difference, right? Just
That's
to
the
be
potential difference. That's correct. That's right. It's a potential difference. So we have.
Yeah.
Okay, so we have a discharge because we have a potential difference. Okay, so when lightning bolts occur, and this has only been discovered in the last 35, 40 years, that observations from space have noticed that when lightning strikes, we have these things called sprites and otherwise known as elves. So there's this electrical phenomena that have been noticed and observed and recorded from space where a lightning strike on Earth from the atmosphere to the ground goes actually into space. It dissipates into the upper atmosphere. And they're called sprites and elves. Everybody on board?
yes.
Okay. So the Earth has an electromagnetic field. And the sun has an electromagnetic field. And the moon has an electromagnetic field. Everybody on board?
Mm-hmm.
No disagreement. So the
Nope.
Earth is a magnet, and it's moving inside of the magnetic field of the sun.
Well, I would say it's moving within the gravitational field of the sun, and that gravitational field precipitates movement of the magnet within the Earth, which then itself creates a very magnetic field.
Okay,
Yeah, I
Jen,
mean,
look, there is a magnetic field.
Are
There
we
is a
assuming that molecules and on a macro scale, the Earth and the Sun are coming together because of gravity or magnetic attraction?
Well, that's where the conundrum starts to happen.
Yeah.
This is where the magic is starting to happen. Okay, so the Earth is a magnetic field. It has a magnetic field. The Earth is a magnet. It produces a magnetic field, therefore the Earth is a magnet. The sun has a magnetic field, therefore the sun is a magnet. So we got two magnets, one orbits the other. We got one magnet literally moving within the magnetic field of another. Can somebody tell me, is there a magnetic or electromagnetic differential? Is there an electromagnetic potential? The answer is yes.
There
So
are
am I wrong?
some potentials, but in order for there to be potentials that are non-trivial, you have to basically observe discharges, right?
Yeah, and
Okay.
lightning would only serve to reduce the attraction, whereas
We'll have to
you know,
observe discharges. We're going to get to that, Jen. We're going to get to that. We're going to observe some discharges, and I might have some screen shares. I hope I have a file. It might be on my external hard drive. I am working with a new computer, so bear with me. I may or may not have these files on my current computer. They may be on my. Anyway.
Is your claim that lightning brings things together?
Is my claim that lightning brings things together? No.
No. Okay.
No, I'm not making that claim.
Okay. Drives things
No.
apart? No.
I'm not making that
happens.
claim either. I'm not making that claim either.
Oh, no, I'm just curious. I wasn't saying you were. Just
No. I'm only trying to go from the micro to the macro in terms of scaling electrical potential.
Okay.
Okay. So now we have the Earth, which is a magnetic. Just think of the Earth as a magnet because it has a magnetic field. So therefore, it's a magnet. The Earth orbits the sun. The sun has a magnetic field. So we have one magnet, the Earth, revolving around the sun, which is a magnet in the sun's magnetic field. So now we're talking about two electromagnets. And guess what? There's going to be an electrical potential. Yes?
yes, it would give some sort of a warble, you'd figure, as things spin around each other, would they not?
So there would be an electrical potential. Yes?
Yes, of course.
Oh,
There's
okay.
always.
Of course. And let me ask you this. Can you have magnetism without electricity?
Can you have magnetism without electricity? I mean, that seems like a non sequitur.
Does you damn right it does.
It depends what you mean by electricity, right? Because we kind of talked
Yeah,
about
exactly. I mean, yeah, if you
Electrical
have
potential.
electrons,
Electrical
you
potential.
have.
How about electrical potential? Let's leave it there.
Okay, if you have electrical potential,
Can you have a magnet without electrical potential? Yes, because natural magnets don't have an electric potential, but they have an inner magnetism.
I think that's false. Now we can.
So you're basically saying that when you
I
put,
don't know. A stationary magnet um, doesn't really have a whole lot of motive force.
well, think about it. When you put a magnet on your fridge, is there electrical activity going on there, or is that just magnetic attraction?
Oh, it's not
It's
just
kind
magnetic
of one and the
attraction.
same.
Can you can't have magnetism without electricity. You can't have electricity without magnetism. Okay, they go hand in hand. That's the
That
bottom line. And fit. I'm sorry, but
Well,
that's fairly accurate.
the
I
magnetism.
wouldn't.
I mean, the magnetism
I
of
wouldn't disagree with that.
the magnetism of natural magnets is caused by the electronic configuration within the atoms. So, in that sense, yes, but it's not a moving electrical field; it's a static electric field.
it is static. That's correct. It's static.
Right. So again, this is down to definitional because for some people, electricity it has to be moving for it to be
And
called.
that exactly is the case.
Oh, but we're still talking about electrical potential. You can't have one without the other. You don't get a magnetism without electricity. You don't move electrons without magnetism. That's just not possible. As
A
far as we
magnet
have
on its
observed,
own sitting on a wooden table is not necessarily electric. If you bring something close to it with an opposite potential, something that actually gives a potential, then yeah, not an opposite potential, but an opposite charge, then sure. But is a magnet sitting on a wooden table electric? It's up for debate.
Well, exactly. Everything's made up of atoms, right? And atoms have electricity in them, so there's like the trivial solution to that.
it's just static. There's still electrical potential. Because if you took a copper wire or a silver coin or a gold coin or something, some metal that is diamagnetic like gold or silver or copper, and you pass it through that magnetic field of the magnet sitting on your table, you are in fact inducing a magnetic current, or electric current is induced in the metal. Okay, electrons are moving. That's just not possible. You cannot do that without the motion and movement of electrons. So electricity and magnetism go hand in hand no matter what.
So that just assumes that the electricity, so to speak, of a magnet extends well beyond the magnet.
Yes.
Yeah, I'll give you that.
So a magnet may be stagnant. You may think of it as a stagnant electric current, an electric current that's really not in motion until it's
Harnessed by
perturbed.
resistance.
Yes, until it's perturbed by the resistance or conductance of some other material, say a plasma or a metallic metal or material like gold, copper,
Yeah.
silver, diamagnetic material. You pass one of those things through a magnetic field, there's a disturbance in the magnetic field. That's how fucking magnetrons work. That's how the thing works at the fucking airport when you walk through it, right?
Mm-hmm.
Okay, so when you
Resistance
walk,
and conductance are effectively the same thing, just the
that's
inverse.
right.
But
That's correct. It's the inverse law of electricity. So when you walk through a magnetic field and you've got something in your pocket that will disturb that magnetic field, electrons are disturbed. So the static motion of pardon me, I'm not a physicist, okay? So pardon my vernacular, okay? When you walk through a magnetic field at the airport and you've got something in your pocket that will disturb that magnetic field, then you are disrupting the stagnant or static magnetic or electrical potential of the magnetic field. And that's how they know you got metal in your pocket. Fair enough?
Yep.
Okay, pardon my vernacular. I'm not a fucking physicist.
Me neither, man.
Okay. Okay. So let's scale up a little bit further. There are many articles that are easily searchable on Google and YouTube where magnetic and electrical Birkeland currents have been detected in space. Okay?
Birkeland
So,
currents. Ever heard of it?
never heard of that?
Nope.
Is that a yep or a nope?
Nope. Googling
Okay.
it as we speak.
Okay. Are you familiar with Christian Birkeland?
Negative.
Electrical engineer from the early 1900s.
Fair enough. I will put that on my list.
Christian Birkeland. He's like the pioneer of plasma physics and electrical engineering from like the early 1900s, late 1800s to early 1900s.
Mhm.
Okay. Jen, if you would like to like Google and screen share and show audience or as we're speaking Christian Birkeland, his experiments or whatever, that would be fantastic. But there are many articles from NASA, from Bell Labs, and other very well known scientists, cosmologists, people in the field who have detected Birkeland currents in space. So we all know that the sun and other stars, by the way, not just our sun, all stars, they put out what are known as charged particles, protons, electrons. Okay, so the sun is emitting charged particles all the time, right? We know them as CMEs, right? Coronal mass ejections, and these are charged particles. They are the cause of the aurora borealis. So charged particles from the sun they blast their way at sub-light speed. I'm sorry, what's all the fucking noise?
Yeah, Mark, could you
My
just
bad.
yourself when you're
I'm
not
about to mute.
Thanks.
I'm listening. It's just the Bose headphones pick up fucking everything.
Okay, so the sun, I'm sorry. Now I don't have to speak so loud because I felt like I was talking over somebody remodeling. No offense, Mark. That was really loud. Anyway, so the sun puts out charged particles, coronal mass ejections. This is what causes what we know as the aurora borealis, the northern lights, and the southern lights. It does it on the South Pole as well. So charged particles, let's think about that. Charged particles, electrons, protons, positive and negatively charged particles, strike the Earth and they create a photoluminescence in the Earth. We call this the aurora borealis. So this is an electrical occurrence. This is an electrical potential between the sun and the Earth. So in other words, the sun, just keep in mind that the sun is constantly putting out coronal mass ejections in all directions. And by the way, so is every other star. So in other words, our entire solar system, and by the way, the entire universe, is swimming in a sea of plasma. Okay, charged particles. The entire universe is an ocean of plasma. And anybody who knows anything about electricity and or plasma knows that plasma is one of the best conductors of electricity. So what we have is, if you look at, and we should maybe do a screen share, maybe pull up the image, the three-dimensional image of the known universe. And it kind of looks like brain cells. It sort of looks like this filamentary, stringy, I don't even know how else to describe it except filaments of strings of stars and galaxies of our known universe. It sort of looks like
the circular one, the one that's encircled the entire known universe in a single image. Is that the one you're
well,
thinking?
I'm talking about the three-dimensional image of the known universe that looks like brain cells. It very much looks a lot like brain, like nerve cells, brain cells. It's very filamentary in nature. It's a three. There you go. Yeah, something like that.
Yeah, I've got a couple here. I've just Googled the known universe and looked
There
at.
you go. There you go. That purple. Yes, that one. That's one. That is one of many. But yes, that one. Those filaments are pathways of electricity traveling. Think of them as cosmic Birkeland currents traveling through the plasma of the universe. And then what we have is, through plasma physics in laboratories, we've discovered what are called Z-pinch, where these plasma filaments, they twist on themselves. Okay, they become a toroid and they twist on themselves. And then they sort of pinch at certain locations. And when they pinch, all that energy is focused in one point. This is what the electric universe people are talking about when they talk about how stars are formed. Okay, this is star formation according to the electric universe thesis. The accretion model is junk. It's bunk. It's junk. None of the fucking models work. That's why we have to have dark matter and dark energy. There's your fudge numbers because their models don't fucking work.
Well, I won't disagree with you that the current model for star formation, which is accretion, is one without any evidence whatsoever. But I have my own model for how stars are formed, and mine's actually validated by science, and it has nothing to do with electricity. So
I think it makes way more sense that gravity pulls pieces together to make stars than it does neutral, effectively, clusters of molecules.
Okay.
You know, why
Look,
would you think
hey,
that there's that vast of a difference? And you also claim that they don't attract each other necessarily through lightning.
Look, we're not, first of all, I am not denying, and neither is the electric universe denying the force of gravity. Okay, nobody denies that. Newtonian physics works. It's a real thing. Gravity exists. We get it. We're not denying gravity.
Okay.
What we're saying is two reasons. Number one, the force of the electromagnetism. All right, put your thinking caps on. Ready? It's 38 to the 10th power. It's 38 billion 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 times stronger than gravity. That's how much stronger electromagnetism is compared to gravity. So this is an enormous force that seems to be ignored by most of cosmology. Okay, they want to invent dark matter and dark energy to make up for the reason that their models don't work, because when they plug all their gravity equations into their models, they can't come up with accretion to form stars, planets, solar systems. It fails every time. So they have to.
So you really don't think that they brought into the equation attraction through magnetism?
They have not, and that's evident.
They have not. Well, it's shit. I had no idea.
Okay, well, just to be clear here, the electric force and the gravity force have a different strength depending on radius, right? Gravity's 1 over r squared, and electricity is 1 over r cubed. So you can't say electricity is stronger than gravity because it depends where you are relative to unity. So on the surface of the Earth, obviously the gravity force far outweighs any electrical forces, because if it didn't,
and that's fucking obvious.
Well, thunderstorms would pick us up if it overwhelmed the gravity force, which never happens, right? So clearly gravity dominates at this scale. And I don't know how you can say it's billions of times stronger when that's not what the evidence says at all. It really depends.
Well, it is if you have millions of volts an inch away.
Doesn't it depend on the radial distance, though?
It clearly does. How could you can't argue with that.
No, of course it of course, it involves radial distance.
Sure. So
What are we
And
arguing about again? What's the more fundamental force? I would probably err on the side of Jen's argument that gravity in the universe is a more fundamental force.
Okay, well, Jen, since you're the one who's hosting the stream and you're the one who can share quicker and faster and better than anyone, do a quick search for, say, NASA articles that are finding Birkeland currents in space. Birkeland currents discovered in space.
How do you spell that?
NASA.
No, Birkeland.
B-I-R-K.
LAND.
Yes.
So the existence of electronic currents or electromagnetic fields in the universe wouldn't mean that gravity wasn't the fundamental force of the universe, right? So anecdotes.
No. Maybe. Well, here's the thing. This is where we run into a conundrum. This is where we run into our argument. Because when you say fundamental force in the universe, this is the problem that we're having. This is the problem that the electric universe is running up against. Because they're suggesting that electricity is, in fact, the fundamental force of the universe. And gravity is it's a subset of the electric force.
I apologize for not being up on any of this theory, but how do they possibly claim that?
Well, first of all, electricity is indeed scalable. Second of all, through many of the observations,
It's scalable, but not in the same.
But not. Wait. It's
exponent
scalable.
that gravity is.
So you're saying it's scalable up to a point?
No. It's entirely scalable, but as you move away from an object, it gets less and less, and more. Well, it gets less and less compared to gravity.
It falls off as 1 over.
That's why we're not getting zapped constantly by the fucking
so,
sun. We're pulled into it constantly.
So if you're talking about moving further and further away, how does gravity be affected when you're further and further away? It's less and less.
Gravity falls off as 1 over r squared, and electricity falls off as 1 over r cubed. So do you understand that r cubed is an exponential function that increases faster than r squared after unity?
My understanding of that is limited.
Cubed versus squared. Your understanding of that is limited. Look at the equation. I'm sorry, Roofus.
No, hang on.
I'll give an example. It's fine. It's not that complicated.
I'm willing to concede because I'm not a fucking physicist.
It's fine, Roofus.
No, it's simple math.
We'll do it for the audience. So what is 0.1 squared?
It's 1.
No, 0.1 squared is 0.01. Okay. So what's 0.1 cubed?
Wait. Hang on. 0.1. I'm sorry. You said 0.1 squared.
Okay, so just to be clear for the audience and for you, Roofus.
Did you say 1 squared or 0.1 squared?
0.1. Just to be clear.
0.1.
I'm trying to establish.
If it was 1, it's unity, and they're all the same.
Unity is where they're equal. And what I'm trying to establish here is that before and after unity, which of the functions is larger changes. Okay? So 0.1 squared is 0.01, right? And anybody can look this up. You can go on Google calculator and just say 0.1 to the power of 2, and it's 0.01, right?
Yeah, 0.1 times 0.1, or 0.1 times 0.1 times 0.1. Yes, there's a clear difference by the number of decimal place or zeros after the decimal place.
So 0.1 cubed is less than 0.1 squared, correct?
Yes.
So before unity, the cube is smaller than the square. Okay? But what about after unity?
It turns right around, doesn't it?
Yeah, what's 2 squared? 4. Right? And what's 2 cubed?
8.
8. So at unity, they're the same because 1 cubed equals 1 squared. But after unity, the cube takes off way faster than the squared. And so the electric field is 1 over r cubed, whereas the gravity field is 1 over r squared. And since after unity, cubed is bigger than squared, the gravity field will be stronger than the electric field at anything past unity. But unity doesn't mean 1. Unity means you have to actually go through the field
Less than 1.
to figure out what unity is, because unity in this case would depend on these like force
The
constants.
potential versus the mass.
Well, there's a force constant in gravity. It's capital G, because the gravity force is gmm over r squared. So G is like some random number, right? So you have to actually go in and figure out what unity was, but it's not that big, because clearly the gravity force dominates on our scale, right?
Isn't that dictated by the mass of the object?
It's dictated by the radial distance between the centers of mass.
No, G. No,
What is
it's been a long time.
G is a constant.
Okay.
I can look it up and put it in the chat. But yeah, G is what's called the gravitational field constant, I think. I'll look it up real quick.
Jen, I dropped a 6-minute video. Would you mind playing that? I dropped it in Skype.
I can play it, but we won't be able to watch it because I'll have to play it over the stream. So you won't be able to see it. So if you guys want to watch it, I can put it in the chat, and you can mute yourselves, and you can watch it on your own computers if you want to, or you can go over to the live stream and watch it while I play it there. And
Can you drop it in my messenger inbox?
yeah, I can do that. I'll just quickly set it up here to play, and then we can take a quick break, and everybody can watch this, and we'll come back with our opinions on that. I just have to set it up real quick.
I think I have like 8 minutes until barbecue's done.
Okay, so why don't we play that video after, and we'll just talk to Mark for.
It's a 6-minute video from Thunderbolt's project. The title is Stephen Quintet, Halton Arp is Vindicated Again. And if you don't, I hope you know who Halton Arp is. Halton, for those who don't know, Halton Arp was Hubble's assistant who took over the project after Hubble at the observatory. Halton Arp was Hubble's assistant. Hubble is, by the way, the guy who supposedly discovered the redshift and the expansion of the universe. And not only did Hubble refute his own findings of the redshift and the expansion of the universe, but Halton Arp actually proved that the expansion of the universe by a redshift is false. Halton Arp proved that shit. And anyway, this video.
I agree with you based on that. Like, I don't think. I mean, the whole permanent expansion of the universe argument comes from the Big Bang, and I deny the Big Bang, so I'm basically fine with anything contradicting an internally expanding universe, because I don't really think that's what we're dealing with.
Well, anyway, here's a video from Halton Arp. I would like for you to watch it and see if you can refute what these guys have to say. Because again, I'm not the physicist. I'm doing my best to represent electric universe.
Well, the thing is, there might not be anything to refute. It wouldn't be a question of refutation of what is going on in the video. It's a question of interpretation. It's the question we're asking ourselves here is, what's more fundamental, gravity or electricity? And I think the main arguments against electricity being the most foundational force are, you can't really predict nuclear reactivity using electricity, or at least there's no clear way to do that in my view. And also this lack of electric discharges that we observe, because if everything was electrical, we would expect the night sky to basically be pure light.
I think that's an oversimplification.
Yeah, why?
Because
it's obviously nonsense.
No, I mean, why? No, yeah, why
everything
would
to
we?
be light, right? You have to make plasma to get light out of electricity, and
No, look, yeah,
you need
exactly.
a potential difference to
No, exactly.
make that happen.
Electricity travels through plasma, and it makes no effect.
Electricity effectively makes plasma.
In many cases, electricity will travel from one place to the other, and there's no visual effect.
well, when there's
That I would enjoy
Roofus.
some information on.
If there's an electrical potential difference, when that difference is minimized due to a discharge, there will be electromagnetic radiation released, which will be light, correct?
If you excite to this state of light. right?
Yeah, only if you excite to the exactly.
There will be
I
some
mean,
type of electromagnetic radiation, whether or not we can actually observe it. There will be
look,
something, but we don't observe
Jen,
any electromagnetic radiation except for the cosmic microwave background, which can be
no,
ridiculous in my model.
no,
I
no,
mean,
it's a
there's
voltage.
always
It's a
there is
voltage potential. It's a voltage potential. There's always electrons moving. There's electricity
true
happening right
story.
now. There's
Yep.
electricity happening right now between me and you, in the air, in the space, in the atmosphere. Right now, electrons are moving all the time, and we're not swimming in a sea of light.
If I were to get my
Okay.
multimeter from downstairs and test my own resistance, it would come up at about 2 megohms, which means that the small voltage that my multimeter is putting across me is actually moving in a very slow, well, very minimal. I wouldn't call it slow because
Well, minimal
that,
amperage.
yeah, very small amperage, right? But it's a fluke. So
No, but that doesn't mean that you're swimming in a sea of light.
no, I'm certainly
I mean, we
swimming
have
in a
the
sea
aurora
of
borealis, which is
electron
exactly
rings.
what happens when the electrical potential reaches a certain degree. Then there's an excitement uh, of uh, of the various particles in the atmosphere which produce light, sort of like a neon or an argon light.
Yeah, you just have to excite the molecules enough to get them to start throwing out photons.
Exactly. Yeah. So, I mean, just because electrons move from here to there doesn't mean you're going to see light. Electrons are moving all the time. Electrons are
Absolutely.
moving in your body right now. You're nothing but an electromagnetic machine. Are you a being of light? Well, if you ask
No.
Yoda, he would say yes. But do I see light when I look at you? No.
Well, we are beings of light.
Wait, I got to chime in here. Do you accept the quantum mind hypothesis?
No, go ahead.
Rufus, do you
Yeah.
accept the hypothesis of the quantum mind?
I don't know enough about it to say yes or no. When I understand
Oh,
about the
fair enough.
what
But you
what
know
I
about Boolean logic, right? You know, like ands, ors, XORs, etc. You understand how binary computing works,
understand how binary computing works.
right?
What
That's
I understand
Boolean
about
logic. Do you think
quantum
that could possibly make up the brain? Computer
binary
bits?
binary computing make up the human brain?
Yes.
No. So
Thank you.
I suppose I would have
So
to
you
accept.
should effectively say yes to that question whenever you're asked, because
Okay, fair enough. I haven't thought about it deep enough, and so you pose it to me, and I'm thinking about it, and I'm going, yeah, I guess I would
yeah,
have to accept the quantum brain, the quantum mind theory.
yeah, because
Yes,
we're yes, no, or maybe. There's no
exactly. Okay,
yes or
fair
no,
enough.
right?
Fair enough.
Okay.
It's just something I really haven't spent a lot of time thinking about. So, okay.
No, fair enough.
Now,
I'm surprised Jen hasn't posed it to you, but glad I got to be the first.
Yeah, I don't tend to like try to push it too much on that stuff unless it actually the conversation leads that way. So we hadn't.
If anybody knows anything about computers, though, you should push that on them and be like, "Does this make sense?" No, it doesn't. So it's got to be quantum.
See me on JF? I mean, this guy's.
Yes, I did.
That's what it's going to be like with most of these fucking assholes who don't believe quantum mind.
Well, he doesn't understand. JF does not understand computers. I will say that publicly.
Yeah, I think it's pretty good argument style that you're using here, because I think most people would intuitively say that their mind doesn't really function the way a computer does, which is essentially like a glorified calculator.
Well, we're programming that computer, right? It's like, oh yeah, do this, or if this, then yes or no. If this, then yes or no. It doesn't explain my brain. That's for goddamn sure.
no, it doesn't.
We can parallel process. We can contemplate multiple things at once. And
Yeah, but contemplate dictates that, who programmed me? I would say it certainly wasn't somebody that had that much time to write out this much fucking code.
Yeah, exactly. I mean,
like, give me a break.
I don't know what the argument is against quantum mind. I mean, people even I just don't know what the fuck they're talking about.
People, I think, are just contrarians, and they don't understand logic.
An argument from incredulity.
Yep.
Is that what it
Lots
is?
of those out there. I like that.
I'm very happy to say that I don't fucking know when I don't know. You know
Exactly. And as you
what I
should
mean?
be.
instead of making some shit up and trying to defend my ego, I'm happy to say, you know what? I don't fucking know.
Yep. Not a physicist.
Yeah, fucking A. Just be honest. Just be honest. Let the ego go. Just let your
Yep.
ego go and say, you know what? That's an interesting question, and I don't fucking know.
But if you do know something, or you think you know something, push it hard until somebody legitimately contradicts you.
Yeah,
You know,
change your opinion
live and
based on
learn, man. Fuck.
change your opinion based on new information. It's that's all it is, really.
Yeah.
That's science, guys. And it shows
That's
you how few people actually give a flying fuck about science.
prediction is one of the key tenets of science, and I don't. I'll bring it up. I don't think global warming scientists have any sort of prediction
Look,
capability.
I'm happy to change my position if you can convince me. But here's the thing. You have to convince me. What I mean by convince me is don't dazzle me with jargon that I don't understand. Because if I don't
Exactly.
understand it, then I'm not convinced. Do you know what I mean?
The
No,
thing,
And if
it's
you
a role
talk
of like
over
a
my head,
tutor or a teacher.
if you talk over my
Yeah,
head, you're not doing very well to convince me. All you're doing is dazzling me with jargon that I don't fucking grasp.
well, the thing is, Rufus, we're not actually disagreeing with you on a lot of these points. Like the mind as a quantum computer, it is an electromagnetic field.
No,
So,
I'm just making a side point.
so
all
the
right.
human consciousness.
Exponents are not physics or physicists.
Sorry. Didn't mean to run you over. Go ahead, Jen.
Well, basically, what we're saying is that the human consciousness is an electromagnetic field, so that wouldn't contradict your position at all. The only question foundationally that we're at odds here for is whether electricity explains everything or only a subset of everything. That's, I think, what it's about. It's not about whether electricity is a thing or not, because we obviously all agree that it's a thing. Otherwise, what has Mark been doing all this time?
Well, obviously you understand that it's definitely a thing, and certainly it's definitely a thing that permeates every aspect of everything that we know about from the micro to the macro. So why would we not continue going into the macro and by that what I'm talking about is like mainstream cosmology and physics when we're talking about like star formation, because the accretion model fails every time, and yet the electric universe not only has a very detailed and well put together explanation, but they have very predictable models. And this is what science is about: is making future testable predictions.
I don't see how a Z pinch predicts stellar formation.
Well, I suggest you spend some more time looking into what these guys have to say, because maybe I'm not qualified to explain them very well. I'm happy to admit that I'm not the best person to talk to. If you want to understand electric universe, go talk to Halton. I'm sorry, Halton Arp is dead. Talk to Donald Scott. Talk to Wal Thornhill, and I'll think of the other guy's name in a second. But
Well, I
they're all
have
set.
that all I need to invoke is gravity and quantum state exclusion, and I can predict stellar formation in my.
What is quantum state exclusion? I have no idea what that is.
We can go into what that is. So think about it this way: is it possible for matter to be infinitely dense?
I have no idea what the fuck infinity is. So when you say infinitely dense, I can't say yes or no. I don't
It's
know what fucking infinitely dense means. I don't even know what that means. So when you say infinitely dense,
it's a
I'm,
thought experiment. So
I'm
Does
not
that mean
qualified.
zero space between
I'm not qualified to even say
one part
yes
to
or no.
another?
I don't know what infinitely dense means.
it means
That's beyond me, and I suggest I would propose it's probably beyond you as well.
well, it's
Infinite.
not. I've got the model that makes the predictions, so clearly I know what I'm talking about here. But the question is it possible to just keep making a more and more dense region, or is there a limit to how dense a region of any kind can be in the universe? That's the
I would say, based on my understanding of fractals, I would say that there might be a possibility that you're correct. Infinitely dense, maybe. Based on fractals, as I understand how quantum fractals and how fractals work to the micro to the macro, Possibly, maybe, but I'm not qualified to make an opinion, yes or no.
Okay, well, I can tell you.
Infinitely dense, does that mean that there's zero space between molecules and they're perfectly arranged, so there's no
Zero
space between them?
No.
Zero space.
From what I understand of the term infinite, then the answer is no, because no matter how small of a space you get, there's an infinite number of spaces in between.
Yeah, but if you
So
have
the answer
everything
is no.
at absolute zero, and it's possible to pack things into.
Is absolute zero a thing?
It's
Yes.
unobservable. It's a thought experiment.
They've been close enough. No, no, absolute zero is a thing.
It can be extrapolated, but that state itself cannot be observed. It can exist, but it can't be observed, because as soon as you observe it,
Yeah,
it becomes not absolute zero anymore. Because in order,
well, obviously, because of heat transfer, yes, but absolute zero is a practical thing.
Yeah, exactly. It exists, but it cannot be observed.
Exactly. Thank you.
And that's the different. That's why understanding quantum stuff is so important, because the difference between existence and the capacity to be observed is actually quite important, because observation changes the state of what you're observing. And if you attempt to observe an absolute zero state, you have to send something to observe it with, which is photons. And by sending photons to it, you're exciting it above the absolute zero state. So yes,
Well,
yeah, you can't have an absolute zero camera.
We cannot observe absolute zero, but it does exist because we can extrapolate it using graphs, which is what Mark is talking about. Like they have.
Well, most of what.
Well,
a fair bit of what you talk about, Jen, is extrapolation. Right?
It's like saying I have a perfect triangle.
It exists.
There's no such thing as a perfect triangle, because the more you zoom into the angles, the more you realize that the angle is off by some subset of a degree.
Have you not used AutoCAD? You can make perfect triangles, no problem.
You know, okay. Well, there's a limit. At some point, it has to stop and say this is the angle.
Parsecs.
Well,
is the limit. Parsecs is the limit in AutoCAD.
Here's what I know. Here's what I know about infinite. Okay. Here's what I know about quantum physics. What I know is that the smartest people in the world in the realm of quantum physics will all say, and they have been on record as saying the same thing. And here's the thing that they say: that if you think that you understand quantum physics, you don't understand quantum physics.
Yeah, I think that's just a psyop, though, to get people to not be interested in quantum mind, because they want us to be dumb slaves. I don't actually think that's true at all.
Not quantum mind. I think that's just a cop-out for the average Joe to not want to spend years of their life studying math. And also, that's fair.
They don't really understand quantum mechanics that well in the modern day. So just to come back to this question of, is it possible to have infinitely dense matter? So consider a situation where it's just purely neutrons, right? Neutrons packed, neutron with zero space between them. That would be your maximum density state, because these fundamental particles have something called quantum state exclusion that operates on them, which basically means that a quantum entity, i.e. a neutron, there can only be one neutron per quantum state. So once you get to that limit, it's not possible to fit any more into the quantum state because of quantum state exclusion, which is something we've observed countless times through scientific experiment.
Well, so the only way I could possibly understand that is if I consider the fractal nature of the universe. And that goes beyond my true understanding of how things really are.
So fractals,
nobody knows the way things really are.
You just need to think about a bunch of neutrons packed together. You just need to think of a cube comprised entirely of neutrons. Is it possible to fit anything else in there? Well, no, because it's already as densely packed as it can be. You don't need to fractals for that.
Well, then that wouldn't be infinity, would it?
Well, that's what I'm saying. It's not possible to have infinitely dense mass. That's where this is basically where.
So you're saying it's not possible?
It is not possible based on what we've observed to do that. So this is how my model predicts star formation, right? So I'm getting to what it is that I'm trying to say here, but you have to accept this axiom first, that it's not possible to have infinitely dense matter. So
okay, well, I was a little bit confused. I thought you were suggesting that it was possible. So go ahead.
I'm in the same boat. I'm out. I don't believe
I'm out.
So basically, the way we predict star formation is you have regions in the universe which are very, very, very dense, right? So they have a lot of gravity, they're pulling together, and eventually they reach the limit of how densely matter can be packed. And at that point, quantum state exclusion will exclude those waveforms from those quantum states, and that is the mechanism of star formation, and that is how my model predicts star formation. So you don't need to invoke electricity at any point. Electricity is a secondary effect because, as I've said, it comes from neutrons, which are not themselves electrically charged.
Wait. You're saying electricity is secondary?
Yes, so the electrical
Not fundamental, secondary.
The electrical potential difference comes about as a result of this exclusion, because when the matter is excluded, it's not excluded in the same form. It's excluded along the distribution potential of the entire periodic table. So when you get new stars, you get a distribution of atoms in those stars that reflects the natural distribution of all of the elements. So you'd have more hydrogen than anything else. Does anyone know why that is?
Lower maximum entropy state.
Thank you very much. Very good job. That is exactly right. So statistically speaking, we would expect an abundance of the maximum entropy state, which is the first quantum state, which is hydrogen. And then we would expect to see other elements in lower proportions based on how much inner energy, or AKA entropy, because energy is the inverse of entropy in a way. So it's all down to how much energy does it take to generate these states. So that's why the higher numbered elements, you don't see those very much in nature, because they're very low entropy states.
I'm sorry, what did you say was the inverse of entropy?
To say that something is a high entropy state is the same as to say that it's a low energy state, because entropy is a measure of how much accessible energy you have. So the higher entropy a system is in, the less accessible energy you have.
Well, I'll give this argument. I think that gravity is constant and electricity is fleeting.
Yeah, that too. I believe gravity travels, it doesn't travel at a speed, it's instant. And electricity travels at a finite speed, voltage potential travels at the speed of light. So those are...
Okay, I agree with you there. Gravity is instantaneous.
Gravity is less likely to develop a static situation.
Gravity is a static. Gravity is static. It's instant. It's instant.
It's always adapting as well. So
there's no speed of gravity.
Gravity's
there's no such thing as the speed of gravity.
If you're putting force on something.
Well, I think the idea here, what you're trying to say, is that because gravity is attractive, it will always precipitate motion, because attraction is motion, right?
Yeah. Well, but if you have two entities that are at the same voltage potential, they're not attracted to each other, they don't give a fuck, but they'll still come together because of gravity.
Oh, that's a good point. Actually, that's a good argument against this.
That might explain why galaxies, the outer arms of the galaxies, move at the same rate as the inner arms.
What might explain that?
Well, your explanation of gravity. The fact that gravity is instantaneous, there's no such thing as the speed of gravity. So when we observe galaxies as they rotate, there's a strange phenomenon that has yet to be explained thus far, that the outer arms of galaxies tend to spin at the same rate as the inner arms. There's no, except it's kind of strange, because when you get very, very close to the very center, there's a higher velocity of the inner stars, but the vast majority of the galaxy tends to rotate at the very same rate. So there's a strange phenomenon that occurs in the rotation of galaxies.
That's because all the galaxies have the same creation point, is the dark matter in the center of them. That's why our galaxy has a shape that's connected to itself. Like the shape of our galaxy is not random. It's a very specific shape that clearly influences itself, because it's, what is it, a double-armed helix or something? I'm not sure what exactly. But
so can we say at this point that gravity is infinitely faster than electricity?
Gravity is instantaneous.
Gravity is infinitely faster than electricity.
You could say that to speak of the speed of gravity is nonsensical, because it's an instantaneous connection.
Exactly. Infinite.
That's how it's. So I don't know if you could say the speed of gravity is infinite, but again, I don't like to think of gravity as having a speed, because the way I like to visualize it is that it's an instantaneous field. That is,
Right, but what else is infinite other than things that are immediate?
sure, you could look at it that way if you want. If that makes it easier to understand, then sure. I just
Well, I
don't.
mean, well, what are the implications of that statement?
I don't know. The implication is that that gravity is instantaneous.
This is where we get really fucked up, because when we start talking about infinite, any subset of the infinite has an infinite number of subsets within it.
No, that's not true. You can
I have no
subset of an
problem
infinite set.
with the infinite.
It's possible to have a finite subset of an infinite set, but you can't parse an infinite set into a finite number of sets. That's the difference. Right? So if I have the
Say
number,
that again. Say that again. Say that again.
it is possible to create a finite set from an infinite set, but you cannot parse an infinite set into a finite number of finite sets. So if I take the real number line, okay, and I remove the number 1 from that, that's a finite set, but the real number line is an infinite set. So every time I take a finite set out of an infinite set, I'm left with the infinite set and a finite set. It's not possible to parse an infinite set into a finite set of finite sets.
Yeah, but can't you just say that gravity is 0 and electricity is not 0?
Well,
Well,
zero,
well,
what do you mean?
doesn't
In terms of speed.
well, in terms of infinite sets, wouldn't a finite set contain within it an infinite set?
No. The infinite is not a subset of the finite. The finite is a subset of the infinite. And there's 2 types of infinity. So that's another thing people should be aware of. There's the LF naught and LF1 infinities, which are different. So this is kind of another subject. Mark, did you want to say your final words? Because I know you have to go for dinner. I just want to say thanks a lot for coming on, and we'll hope you'll join us at another.
I enjoyed it.
Yeah, it was
Yeah, I
great.
enjoyed it too. I hope we speak again, Aaron.
Yeah, right on, Mark. Good.
I'm gonna go eat some pork on the Barbie, and
oh, you're gonna make God cry.
God cries every day, doesn't he?
God
Somewhere in the world, God is crying.
God doesn't give a shit what we do, and that's a good.
How could he? Yeah, apatheistic is probably the way to be in this.
Hey, you're not wearing mixed fabrics, are you? Jesus Christ! How
It's mostly
dare
cotton,
you?
I would say. I got some Chinese writing. Well, they didn't. It's English, but they wrote it. All right. Yeah, you guys have fun. Very interesting.
Right
Lovely
on,
to meet y'all.
Nice talking to you. Seriously.
I'm gonna go drink some more beer and
Enjoy
cheers.
your evening.
Cheers. Thanks.
You as well. Yeah, that was awesome.
Okay, Rufus, you want me to play that video?
Well, you're not prepared to play it like on the live stream so everyone can see it, right?
That's what I was going to do, actually. I was going to.
Oh, fucking do it. Fucking do it.
You just won't hear it. So if you could just mute yourself, and we'll come back in 6 minutes.
But everybody else will hear it.
Everybody else will hear it, and if you want to watch it, you can just tune into the stream.
Oh, okay.
So if you don't mind muting, I'll start it up.
No, I'm gonna run to the bathroom. Go ahead. It's only 6 minutes. Play the video, and then we'll come back and talk about it. And I'll be back in 30 seconds, and we'll talk about it.
Awesome. Thanks again for coming on.
Cool.
I'll play that right now.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The following presentation is an adaptation of the Mel Atchison Picture of the Day article, another fogged image of Stephan's quintet. The link to the article may be found in the description box of this video. This image of Stephan's quintet is befogged with the same obsolete commentary as previous images. The foreground galaxy, collisions, shock waves, and heat. The foreground galaxy on the bottom left is believed to be in the foreground solely because of the consensus belief that redshift is a measure of distance. The foreground
so I
galaxy
just
has a
realized
redshift
I don't really
Z
want to get
equals
a copyright strike, so I've put the link in the chat for those of you who want to check it out. I will play an intermission here for everyone, so you can just enjoy
The
the 4-minute
consensual
intermission,
conclusion
and
is that the
I'll
foreground
play the
galaxy
longer
is
intermission. So if you
250
want to watch the
million
entire
light years
video, you
closer
can.
than
But
the
yeah, I just
others.
realized I don't want to get a
This
copyright
belief in
strike on this
redshift as
channel,
a
and this
cosmic
looks like the
meter
kind of
stick
video
has been
that would give me a
disproved
copyright
since the
strike. So it's in the
No.
chat.
1960s.
No,
But
trust me.
facts
Trust
seldom
me, Jen.
affect
Trust me. Don't worry
institutionalized
about
I
it.
belief
just don't want to
systems.
risk it, so I'm going to play an
Unremarked is
intermission.
the
People
fact
can
that the
watch it, and then
differences
we
in
can talk
redshift
about
of the
it after.
background
So if you can
galaxies
just mute
place
yourself,
them,
we'll do a
under consensus
5-minute
belief,
intermission, and
farther
then
from
we'll
each
come
other
back
than the
after that.
foreground galaxy is
All right,
from
at
the
least
Milky
play a
Way.
couple of minutes of this video.
Does that make the
Okay, I'm not
foreground
going to play
galaxy
the
a member
video.
of our
Can you just
local
mute yourself,
group?
please, and then we'll come back.
Apparently, the illusion of foreshortening with distance works on beliefs as well. Another fact that's consistently overlooked is that the bright ionized hydrogen regions in the background galaxies are
thanks for sticking around, everyone. We'll be wrapping up shortly, but I've had a chance to look at this video, and it's very interesting. So I appreciate it for you sending it to me. I think there is a lot of truth to it. I do think there are forces that operate over far greater scales than most people realize. And I think the strongest evidence for that is basically the shapes that we can observe. So I'm just going to pull up real quick Milky Way. And I'll give an example of what it is that I'm talking about, because the Milky Way itself very clearly has a shape that is self-connected. So I'm not sure if people know what I mean by that, but if we have a look at the pictures here, this is a good one. You can see in this image here of the warped Milky Way that it's not perfectly symmetric, but clearly it has some type of symmetry.
It also looks like a bar magnet in the middle. I would like to point that out. If you go back to the other screen like 2 seconds ago.
Are you talking about one of these images?
Yeah, the image you showed like 2 seconds ago.
This spiral one?
Before the one I'm looking at right now.
Okay, so I've got a spiral one.
Right there.
You're talking about this sort of yellowish?
Yeah. Yes.
Absolutely. I can absolutely see why you would think that this is a magnetic field, and I do agree that there is some type of magnetism going on here. I just think you need to also consider gravity in order to get the full picture of what it is that's going on.
Okay, no, nobody's denying gravity. Okay, I'm not denying it. The electric universe people, you know, they don't deny gravity or Newtonian physics. Nobody's denying gravity. Okay.
Right, we're just basically disagreed as to whether gravity has its origins in electricity or vice versa.
Right. I would suggest, as a super duper layman, and I'm not necessarily a super duper layman, I've got some knowledge, but I would suggest that gravity is in fact a subset of electromagnetism. And I think that's been proposed. I think there's some science behind it. And I guess I'll just leave it there because I really don't have the science background to back up that statement.
Awesome. So we'll both come back to this in the future. I think it's been an interesting discussion, and from what I can see in the audience, there are a lot of people interested in this. So I really do appreciate you taking the time, Roofus, to talk to us. As I said earlier, Roofus's channel is in the comments for this video. Please check out the link. I've shared it twice in the chat if you're interested, and we'll come back and we'll discuss that video as well as any other points that may be of interest. So I really do appreciate you coming on to discuss your subject of passion. And I really appreciate keeping the stream ultra classy. And I look forward to our next chat.
Cool. Well, look, let's go ahead and plan on soon. We do a third installment. And what I'll do, I have an external hard drive because I'm working on a new computer. My old one crashed and I had to suck it. I had to pay someone to suck everything off my old dead computer onto an external hard drive. I've got a file that has all of my Electric Universe presentation stuff. I've been interviewed 2 or 3 times and I've got a whole file worth of presentation stuff. I would like to come on and show you what I have to sort of bolster the argument, and some of it is going to be like images of like hexagonal craters and things like that are strange phenomenon on moons and planets and stars and Saturn, things like that are really hard to explain, things that NASA and cosmologists tend to scratch their heads over, and also things that the Electric Universe people, not only do they not scratch their heads over, but they're also the people who actually predicted these phenomenon, and that there are scientific experiments, laboratory experiments that actually show that these craters and phenomenon are actually not only predicted, but they're reproduced in laboratory experiments. And so I've got a whole presentation that I can give you if you'd like to have me back, as long as I can do a big old long screen share presentation, and we can go over that stuff on another time.
Oh, yeah, absolutely. We'd love to see that. And I'm sure the audience would be totally fascinated. As I said, I think there is a lot of truth to this Electric Universe thing. And even if it's not the full picture, it will still yield tremendous insight into the inner workings of the universe. So thank you again so much. And we'll say goodbye for now. I'll be streaming later, probably with Gandalf. So check out his channel, and that should be a good one. We'll talk to everyone real soon. Bye-bye, Roofus.
Thanks, Jim.
Bye.